4 UEs that we will show the demo based upon, where the mobile network will be modeled by the Expway e-box, and then the CDN is modeled from Akamai. So the e-box performs all the functions that you would have in a mobile network, from the BMSC for multicast and the P gateway to the SGS for unicast, including the eNode B. And on Akamai, we have a content server going into an actual Akamai cache. Ghost is our internal name for it. It stands for Akamai Global Host. And then the mobile edge is our new platform that provides the interface and the signaling between the cache and the BMSC and the mobile network. So the demonstration is this. So we have 4 tablets right now showing, actually let's reset them to get to the unicast state for a moment. So this may take a second. So here at Mobile World Congress, we're actually using an actual LTE band. Actually, this is band 13. So we had some issues in the first few days just because of interference issues. So this is why they're mounted down here as opposed to sort of more upward facing, because we wanted them to be as near to the antenna as possible. Later on, we'll sort of show. So we have here sort of the Expway antennas for the e-box, and in the back we have the e-box itself as well as the RF unit. So we have 4 units that are looking at that are showing unicast stream. Up top you can see what's being shown. You see that there's unicast. So they have 3 of the devices that are showing one stream type. The other one is showing a different as unicast. And at the bottom, we have the unicast RAN utilization. So for 4 devices, each is about 1.5 megabits per second. So we have a total of around 6 megabytes per second on average for all 4 devices. Yeah. Oh, I switched to broadcast? Okay, I switched to broadcast by accident. But you saw that when I switched to broadcast by touching the UE to go to 1, 3 of the devices that were on unicast, we switched it to 1, so you can see that the RAN utilization went down to about 1.5 megabits per second because the broadcasts are all using the same channels, and there's now only 1 stream that is using unicast. If I switch that unicast channel to the other, it should connect at broadcast because we're going to be going from the Red Bull dash stream to the skiing stream. And we've seen that it's happened already on the devices, and then now it shows up here on the screen. So all of the devices are looking at showing the same video over broadcast, and we see that the unicast throughput has dropped down to 0.
That's the IP that's going through.
Now, if we want to switch one back to unicast, so
you switch a channel.
This is switching back to unicast. You'll see it's gone down to unicast. The unicast RAN utilization has gone up to 1.5 megabits per second. But we're still on broadcast for the other 3 because our drop threshold is 2. So when we switch the next one over from broadcast to unicast, you'll see them all drop down to unicast. So let's make sure that happens. So we see it unicast over here. So 2 has dropped down to unicast, and what we should start seeing is that the other 2 should be dropped down to broadcast 2, unicast 2, and it has happened. So we've seen they're all on unicast, and suddenly we're also seeing here that the utilization has jumped up to 6 megabits per second, 1.5 megabits times 4. So the goal of this demonstration is to show that Akamai, as the provider and the deliverer of the data, can signal effectively to the LTE network about when it needs to switch and how. And why is this important? Because as more and more traffic becomes encrypted, it will become impossible for a mobile network to understand who's watching what and where. So the ability of the CDN to provide that intelligence back to the network, the mobile carrier, helps enable this technology and move it forward.
And it's done dynamically, right, Shikhar, as you showed, so you don't have to wait.
Yeah, so the goal is that it's done dynamically. Right now, this is a new feature that was standardized in 3GPP Release 13. What's currently deployed is that people have to do static provisioning. So they have to actually decide up front or predict which content will be popular and nail up the channels. which for a mobile operator, you're taking risk. You're actually making a risk that more people are watching that channel. And when you've allocated channels from unicast to multicast, you're reducing your capacity, which means you're reducing your potential revenue. So it's a risk that not a lot of people like to take. With MooD, when you can switch dynamically, when you know that there's demand, you are eliminating the monetary risk to you.
Where's the software side network?
Which one?
Well, for the solution.
So for the solution is that the BMSC is actually a network element in 3GPP that will be deployed within the mobile network. The multicast gateway is also a network element within the mobile network. Generally, it's actually the same box as the S gateway. It's just doing the multicast. On the devices themselves, there's actually a middleware that runs in user space that connects to the broadband transceiver to be able to dynamically change from the unicast channel to the broadcast channel without dropping the session.
What level of the network is it? Is it like RNC or media gateway?
Which one? This one, the BMSC, it's a separate element. It's in the packet core. It's in the packet core. So it's actually, logically, for multicast, it goes through the BMSC as one stream, which is a flute, which is UDP plus tech, and the multicast happens in the gateway and then in DNOP. For unicast, it goes through the standard mechanism, P gateway, S gateway into the UNOP. There has to be, for right now, for the technology, all of the players that are showing the video have to be aware of this technology because they have to call the APIs. So it's not something that is purely network-centric. You cannot implement this in a network and without touching the app. So this is where also Akamai can provide value because we have our software into many of the app players from our own customer base.